Namaste and welcome back to the Python class. My friend, now it's time for us to try and understand the most fundamental concepts of object orientation, or in other words, the pillars of object orientation, or in other words, the design principles of object orientation. I am sure you guys have heard these words somewhere in your life: encapsulation, polymorphism, inheritance, abstraction. I'm sure these words you have heard. But what do they really mean? And why does an object-oriented developer have to understand these concepts? And what is the advantage he is going to reap by learning these concepts and more is what we are going to be exploring in today's class. But to do that, I would like to just take an example. If in case you recollect, we had discussed about a food delivery app which looks something like this, wherein if in case you're hungry like this gentleman, all you have to do is take your phone out, go and order your food online from the application. The moment you place an order, that order reaches the restaurant and the restaurant accepts the order. Soon after that, the chef is going to be preparing your dish, and once it is ready, the delivery agent comes, picks up the food, you have given him his location, he automatically reaches your doorstep, and there you go, hot delicious food served at your doorstep. This was the food delivery app that we had discussed. Now, I would like to look at it from the design principle perspective of object orientation. I would help you understand where these words of abstraction, of inheritance, of aggregation, of composition, of encapsulation, and all this, how do they fit in together? Well, let us not waste any more time. Let's dive into the concept. Now it's time for us to look at this application from the design perspective. Now, what do I mean by the design perspective? Please understand, if in case you take this food delivery app idea and present it to a developer who has to develop this for you, then first thing he's going to do is he's going to analyze your idea, try to understand whether your idea is possible or not. He's going to do requirement analysis, etc. Now, all of this is technically called as the analysis phase. But let us assume your app idea passed all the tests and now is an app which can actually be turned into reality. Then the developer has to now enter a phase called as the design phase. Now, what does he do in the design phase, if in case you ask me? Let me run you through it. First and foremost, you know that there are, after all, objects even in this application. If this world itself is nothing but a collection of objects, obviously your app, which is trying to give a solution for a problem present in the real world, is naturally a collection of objects. And what are the objects, if you ask me? We had identified these objects: customer, restaurant, delivery agent, food item, etc., isn't it? As a software developer, you need a means or a way to represent your project in a pictorial manner, right? Because you're not going to directly start by writing code. First, you must create a general structure of the entire project, which is not code, but visual representation of the code which has to be written, and then finally provide it to your development team, who's going to now convert it into actual code. Now, how do they do that? It's very simple. They use a way of pictorially representing code, technically called as the unified modeling language, or what in everyday terminology we call in short as UML. I hope you're able to think. Now, what is a UML? See, very simple. You had not only identified objects, you had actually gone one step further and you had realized that in the real world, objects has state and behavior, or has part and does part. Naturally, even these objects have state and behavior, and different states and behaviors we had identified. For example, name, email, phone number and address is the properties about a customer which our app should capture. Selecting a restaurant, selecting a food item, selecting the address, placing the order, cancelling the order, making payment, availing discounts, probably these are the behaviors which the customer needs to exhibit on your food application. For a restaurant, maybe it's the name of the restaurant, address, ratings and items. Items meaning the food items, which you probably have to capture in your app. But when it comes to behavior, it is confirming the order, adding a food item to the menu, deleting a food item to the menu. These are probably the behaviors which a restaurant has to exhibit. Of course, we can be looking at it in greater detail, identifying more properties and more behavior. But I think for a general example purpose, this much would suffice. For a delivery agent, probably it is the name of the agent, ratings he has received, his phone number. What is the behavior? He could probably confirm that he picked up the food, he could confirm that he has delivered the food, and he could probably also access the contact number of the customer. But what is interesting is if in case you look at the last one, which is food item, which has only state and not behavior, not because I have forgotten to give its behavior. My friends, sometimes in the real world you will be encountering such objects which in your software project you need only its state and not its behavior, or probably sometimes it cannot even exhibit any behavior. For example, food item like a pizza. Yes, you'll need its name, you'll need its price, you'll need its ratings, votes, etc. But why would you require behavior? Now, what is the behavior of a pizza? The other objects can exhibit behavior on the pizza, but pizza from its innate nature does not have any way of exhibiting behavior, right? So technically these kind of objects which has only properties or state, we call them as enumerations. More about this down the line, we will be looking at it. But now coming back to the UML side of things, please understand every object belongs to a type, I have told you. And type in programming is what is technically called as a class, and it is using a class diagram that we can represent a class, its state and its behavior. And how does it look in a UML? It's very simple. It is just a rectangle like this, with the name of the class as the first thing. And you can see how you should read this is, you have a customer class. In that I will create two sections. In the first section, I will place the state. Also, I will be telling what is the type of each of those state members. For example, name is a string, email is probably a string, phone number is an integer, address is probably another string. Like this, I will mention those details also. Now the second half has been reserved for the behavior, or what are the functions or methods which that class must contain. I hope you're able to think. Same is the case for the other guys as well. I can certainly be creating, but as you can see for the last guy, interestingly, it has only the state part, because this is technically referred to as an enumeration, which contains only and only the state part of things. Awesome. Now you understood, okay, I can represent a class, its state and behavior using a UML diagram like this, as simple rectangular structures. Now the developer will go one step deeper, and he will see that, hey, all these different classes that I have identified, are they interrelated to each other? Do they have any relationship between each other? Now, what do you mean by relationship, you must be wondering. Let me rearrange this a little bit so that you can understand exactly what I'm trying to tell you. Now, my friend, you must look at it. Restaurant has a customer. Wouldn't you agree? Restaurant has a delivery agent. Restaurant has a food item. So don't you think it has a relationship which the restaurant shares with the other objects? If in the real life there is has a relationship, and you being an object-oriented developer and Python being an object-oriented programming language should obviously be able to provide you a means to establish this real-world relationship. And can has a relationship be achieved in programming? 100% it can be, if in case you make use of a concept called as aggregation and composition. Now, what do you mean by aggregation and composition? I will show you. But first of all, in this UML, how do we show has a relationship? It's very simple. To show that restaurant has a customer, you must draw a straight line with a diamond tip like this. And that is only called as has a. The moment any developer reads it, he will know this has a relationship. Accordingly, he will do the coding. And how to do it, I will show you. Similarly, same is the case with the delivery agent and the food item. Both of them, after all, share a has a relationship with the restaurant, and hence these diamond-ended arrows. Any confusion till here? But I told you in has a, there are two types. There is something called as aggregation, there is something called as composition. Now, what do we mean by that? Please look at it. A restaurant has food items, But don't you think the relationship between the restaurant and the food item is very deep? Because the existence of the food item actually is totally dependent upon the existence of the restaurant. Or in other words, the food item is present within the restaurant and it cannot have any individual existence. If the restaurant goes or disappears, then obviously naturally all the food items which the restaurant was serving is bound to disappear along with it. I don't think you could disagree with me. Or another way to paraphrase this would be that the restaurant is composed of food items. It is a composition relationship. It is a tight bound relationship, but 100% it is a hazard relationship as well. But restaurant and your delivery agent, they do not share such a deep bond with the restaurant like the food item, because if the restaurant goes, yes, the customer is going to find another restaurant. The existence of the customer is not interdependent with the restaurant, neither is the delivery agent, because the delivery agent can always deliver for any other XYZ restaurant. Any confusion till this point of time? So, how do I differentiate between them? It's very simple. Now that you realize there are two types of hazard relationship, aggregation and composition, let me show you to denote composition. All you have to do is this diamond shape arrow, you have to color it or shade it like this. The moment you shade it like this, it is understood that it is composition. Accordingly, the developers are going to write code. Whereas if you leave it unshaded like this, they know it is hazard, but it is aggregation, and hence they will treat them accordingly. I hope you're able to think. Aggregation and composition. My dear friend, I hope you're able to think that these design principles exist for a particular reason. Is that all, if you ask me? Certainly not. Let us assume that this development team, which is responsible for this application, one day come up with a new idea, because app developers have to keep coming with new and exciting features in their app. That is how the app stays relevant. You cannot have one feature from day 1 till day 100. If you take any of the app, of Facebook, over the years, how many new features have been brought in and how many new features are being brought in. Same is the case with an Instagram. Same is the case with any application you take. If it has to stay relevant, they have to keep updating, keep bringing in new and new features. Let us assume this dev team here decides that, hey, let us bring a concept of a platinum customer. Now, who is a platinum customer? A platinum customer is just like your regular customer, but with extra benefits in the app, because they probably paid a certain subscription amount every month, which avails these exciting offers further. What do I mean, you might ask? For example, a platinum customer obviously is going to have a name, email, phone number, address, much like your customer. Obviously, being a platinum customer, they would have something extra. What is that, I will tell you, but all these behaviors also they would be having, just like a customer. They can also select restaurant, all that they can do. But being platinum, they have something like platinum ID, which shows them that they are a platinum customer, and credits, which basically is a certain point system which they can be availing to, which they can be exchanging to get some discounts, special offers, etc. And when it comes to the behavior, platinum customer has free delivery. A platinum customer also has something called as exclusive offers, which are offers in restaurants which are only and only available to platinum customers. Now great, they did that. But this guy, who is the head of this development team, if in case he creates and he starts to code this from scratch, my friend, this guy is not a good developer. And as a matter of fact, he immediately realizes his mistake that, oh, I have done a huge blunder. You can look at him. Why, if you ask me? That is because I wanted to clearly observe the customer and the platinum customer. My friend, after all, don't you think other than these two extra state parts and this one extra or two extra behaviors, everything else is exactly the same between a customer and a platinum customer? Then if it is exactly the same, don't you think it would be common sense that you can take the code which you had written for customer, reuse it here, and just add that extra features which makes a platinum customer different from a customer? Don't you think code reusability would have been the way to go? Is there a way to do it? Yes, and he also realizes that there is a better way to do it, because as you can see, only the one which I have not colored is different. Everything else is the same. Any confusion till here? So what happens here? You ask me. Well, very simple. All he will do is, he is going to establish a relationship between the platinum customer and the customer. What is the relationship, if you ask me? Please understand, I'll remove all this from the platinum customer. I will make the platinum customer inherit all that it requires from that customer class. And that relationship is only technically called as inheritance. See, I've inherited. After inheriting, all I will do is, whatever is extra, that I will extend the code. I will add that extra code. So like this, I'm going to just add that platinum ID, I'm going to add that credits, and of course in the behavior, free delivery and exclusive offer. If in case you do this, then such a relationship is not of hazard. Such a relationship is that of inheritance, and inheritance is always referred to as is a relationship, because you can read platinum customer is a customer. Wouldn't you agree with me? Yes, but there is something different about it. Yes, that difference you focus on. Rest you inherit, rest you reuse. There are so many advantages to inheritance. It is incredible. Let me show you a few more advantages. But why that is called as is a relationship, I hope you are able to think. Because even if you read it, it makes sense. Platinum customer is a customer. When you say is a, what you are trying to do is inherit. I hope I am clear. Now, let us assume that this was the case. You have customer and you have platinum customer. Now these dev teams think, hey, listen, our company has become very successful, our app has made it big, and now it is time for us to, reward our employees by giving them some kind of a special access to the app and special discounts. So what they do is, they now decide to create another class called as the staff member class, which is what I'm just showing like this. Now what I want you to understand is, don't you think a staff member is also a customer, but with some extra benefits? Again, tell me foolishly, will you code everything from scratch, or now that you know inheritance, will you reuse? Obviously, once introduced to the concept of inheritance, there is no going back, because people see the benefit of code reusability, and hence all I will do is, I will make the staff member to inherit from the customer class, but I will only focus on those special features which is not present in the customer, like availing special discount is a special feature, rest everything else I am going to inherit like this. So don't you think code written once was reused 2 times? And if it is reused 2 times, don't you think it has reduced development time and development effort? Don't you think production of code can be done faster? Don't you think releasing of new features can be done faster? And don't you think the byproduct of doing all this is that naturally you as a company will be faster in your working, and the more faster you are, the more money you make. And don't you think profits are also increasing? So inheritance has multifold benefits associated with it. So this is only inheritance. Its advantages in simple words is code reusability, reduced development time, and easy maintainability. Now what do you mean by easy maintainability? How does it make maintenance easy? My friends, simple. Assume I'm going to release a new feature for every customer. Doesn't matter whether it is platinum, doesn't matter whether it's staff member or a regular customer, which is the customer, if he or she chooses to, can provide their live location details to the delivery partner. So the delivery partner knows exactly where you are and can deliver the food to you. Because sometimes you are maybe in the middle of the street somewhere and you want food. You're not at your house or at your office. You're not in any building as such. You could be standing in the roadside. You can still order food. Now, all I have to do is, I don't have to foolishly go and make changes inside every one of my class and add that new feature, because inheritance is there. What I mean to say is, all I will do is I will go to the class in the top most of the hierarchy, and which is that class? Customer. Technically, the class on the top of the hierarchy is called as the parent class. The class at the bottom of the hierarchy, which is inheriting, is called as child classes. There are many names. This class is sometimes called as the base class. These classes are called as derived classes. These classes are sometimes called as child. These classes are called as super, because they are like the parent class. Irrespective, I will go to the parent class and I will add that new feature. Provide live location. Just because inheritance exists, automatically that feature gets inherited into the staff member class. Automatically that feature is also going to be inherited into the platinum customer class. And this is the internal implementation details of my application. As you can see, there is more to it than meets the eye. Any confusion? I think you're able to think. But now tell me, as a customer, do you care about all this? The person who's using the app, would he be interested in knowing how many classes are there, whether the classes are related in a has a manner, are the classes related in a is a manner, is it aggregation composition, is it inheritance? Does he care? He does not. Is why you have to think about what is the interface which you will be giving for the user, and that interface must hide these internal implementation details. Because as I'm saying, what does the user see? He sees the food items. Assume he wants to eat something like a pizza. He clicks on it. Next, what does he see? He sees the different restaurants available. He is going to select a particular restaurant. After which, what is he going to do? He is going to provide his location. After which, what is he going to do? He is going to go and proceed, which is the payment methodology which he wants to use, which is what I am just showing like this. After selecting the location, he is going to decide the payment. This is all he sees, my friend. And he is not bothered about all these details, which you should not provide to him. Secondly, you must hide it from him. He doesn't care. Much like you could be using the most sophisticated car in the entire planet, but once you as a user sit behind the steering wheel, all you see is 3 pedals: a brake, a clutch, and a acceleration. But upon clicking the clutch, upon pressing the clutch, upon pressing the acceleration pedal, upon changing the gear, internally that internal combustion engine, so many things must be happening. So much of marvelous engineering is there behind us. But all that has been abstracted from us. All that has been hidden from us. We don't care. But the engineer who designs the car cares. Similarly, the developer cares, but not the user, not the driver of the car. And this concept is only technically called as abstraction, which means as an object-oriented developer, you have to start thinking in terms of abstraction also. So I think I've given you a general idea of why these object-oriented design principles exist. These pillars of object orientation exist. Now all that remains for us is to take up one thing at a time. Let us start with encapsulation. Let us proceed to inheritance, and then finally understand what is polymorphism and end by understanding what is abstraction. And this is going to consume a lot of time and is going to consume a lot of thinking and patience from your end, because this will set the foundation and will decide how good or bad of an object-oriented developer you are going to be, and even otherwise is one of the most commonly asked interview questions in any programming interview. So without wasting any more time, let's start.